Good evening, students. How are you? This is Ankit Joshi. I welcome you all to India's largest live learning platform, Gradeup. So, today we will learn about the applications of multiple integrals. Hello, Karthik. Hello, Aman. How are you? Shantanu. Good afternoon. It is good evening. In fact, Manoj Chauhan, Ashish, Ravish. Good evening, beta. Yes. So, in our previous classes, I am also fine, Shantanu. Shantanu, where do you live? Have you attended any of my classes in offline mode earlier in somewhere in some other institute? Hello, everybody. Guru Bhai, good evening. So, good evening, all. So, in our previous classes, recent classes, we have seen multiple integrals, double integrals, and triple integrals. For double integrals, I have given you four different methods, four different techniques. And for triple integrals, we have seen two different varieties in yesterday's class. Great. So today we will be going to learn the applications of multiple integrals. So there are many applications, but as far as the scope of GATE and ESE is concerned, we will be talking about area and volume only. Okay, Shantanu. I have been to Bhubaneswar many times in past. So this is about me. This is me, Ankit Joshi. I have been teaching in this domain for more than 15 years. It will come around, say, some 18 years. So my subjects of interest are engineering, mathematics, analog circuits, and signals and system. So by observing my subjects, you would come to know that yes, I am from electronics background. So I want to share this information with you. So these are the paid courses going on Gradeup platform, Gradeup app. So Gear Up Gate 2021, Rank Up Batch Gate 2021, and yes, Vision Batch 2022. So this batch is basically for yes the early starters. They can just join this batch. If any queries you have, you can contact at the number given below 96500529004. I request all of you to hit the like button. So this will be the faculties dealing with the batches: Rakesh sir, Dheeraj Sardana sir, Abhinav Negi sir, along with me. And yes, we have Ramana sir, Sanjay Rathi sir, Ashutosh Saxena, and the prominent Chandan Jha sir. So we have these faculties with us. These are all experienced faculties, expert in their domains, expert in their subjects. You can take the advantage of them. So if at all you plan to take the Gradeup Super subscription, you can use my code Joshi20, Joshi, Joshi20, so that you can avail a discount of 20%. So here we are. In our previous classes, already we covered double integrals and triple integrals. While covering double integrals, I have shown you four different methods: direct integration, change of order, region-based double integrals, and double integrals using polar form. So Gogoi ji, I'm having pen and board here adjacent to me, but the thing is, yes, I have not insisted by the team to do so. That's why I'm teaching on this platform. But if you be with me, that will be also helpful for you. Sirisha, how are you? Good morning, good afternoon, and now it is good evening. Yes. So starting with the applications of multiple integrals. So we will be focusing on, yes, of course, Guru Bhai, you can see the previous videos. You can search linear algebra Gradeup. You can search integral calculus Gradeup. So you will be able to see my videos on YouTube platform. Moreover, all of you can follow me on Gradeup app. So I conduct free sessions on Gradeup app as well. So I request all of you to download the Gradeup app, and moreover follow me on Gradeup app so that you will be getting notifications regarding any of my free classes there. Okay, so we have two platforms where we provide the free lectures, that is on YouTube and Gradeup app. So sometimes I teach some chapters, some topics on Gradeup app as well. So download the Gradeup app and do follow me on Gradeup app so that you will be notified regarding any of the lectures and their updates. Yes. So suppose you want to calculate an area bounded using double integration. Hafiz bhai, vector calculus, a lot of lectures on app as well, and some lectures are there on YouTube also. Bounded area. देखो बच्चा, initially it appears that I teach slowly, but this is the only way by which we can transform the concepts. See, going in a Baba style, going quickly, just it's a fashion now, but transformation will not be there. So I am a bit slow in my approach so that each and every student should gain something out of these lectures. So bounded area, let us denote it by A. So suppose we are having XY plane No, beta. You just download the app and just your basic details only, email ID and all, nothing. Basha bhai, I am fine. Hafiz bhai, what I want to tell that everything cannot be obtained in the free classes, but of course you will enjoy the basics. At least you will not be stucking up in your approach. That much portion is there on the app as well as on YouTube. See here. If you want to calculate this bounded area, देखो बच्चा, this area is lying in the XY plane. This region is lying in the XY plane. Let us say the name of this region is R. So how to calculate this bounded area? You can calculate this by double integration over this region R dx dy. So if you double integrate, if you do the double integration of 1 over this region R, then the answer will be nothing but the area bounded by this region. Okay? Yes, sir. Now, if you have this region represented in polar form, then what you can do? You can convert this entire region into polar form. So, bacha, what is the conversion for dx into dy in polar form? In polar form, the conversion is r dr d theta. Okay. So, please take care. If you have curves defined in Cartesian form, you can use the first formula. Whereas, if you have the curves mentioned in polar form, you can use the second formula. So these are the formulae, these are the expressions to calculate area using double integration. Okay, so this is in Cartesian form and this is in polar form. Okay, I will start with the first question, because unless and until I solve a question, you will not get the proper confidence. Okay, so we'll start a question here. solve equation. We'll do equation here. The area lying between parabola and the line. Okay, a parabola is given. देखो बच्चा, parabola is given as y equal to 4x minus x square. Now see here, I am bringing these two terms on the left hand side and take y to the other side. Now लालिया को बुलाएंगे, लालिया means red ink. So add 4 on both sides. So now what you are getting? Sir, we are getting x minus 2 whole square minus common on the right hand side, y minus 4. Okay, so please concentrate here. Please concentrate here. देखो बच्चा, suppose you are having this parabola. This is symmetrical about y-axis. So this parabola is x square equal to say 4ay. Its vertex is at the origin. If this parabola is inverted, then its equation will be x square equal to minus 4ay. Still it is symmetrical about y-axis. Are you following? Yes. So if the degree of x is 2, and degree of y is 1, the parabola will be symmetrical about y-axis. This is called as vertical parabola, either opening upward or opening downward. चलिए पीछे आते हैं. So here also degree of x term is 2 and degree of y term is 1. So this is also vertical parabola. But right hand side is negative. See here, when right hand side is negative, the parabola is inverted. उल्टा होता है. Vertical, inverted. Now, if you see here, we are subtracting something from x. What is subtracted from x? What you are subtracting from x? Sir, 2. What you are subtracting from y? 4. So, this 2, 4 is nothing but the vertex. This 2, 4 is nothing but the vertex. Vertex of the parabola is 2, 4. Now, please see here. In this, vertex is origin. What you are subtracting from the x? Sir, 0. What you are subtracting from the y on the right hand side? देखो बच्चा. What you are subtracting from the y? Sir, 0. So vertex is 0, 0. Vertex is 0, 0. So comparing with this, which values you are subtracting from x and y? 2 and 4. So 2, 4 is the vertex. So I got a rough idea. Of this parabola. Okay. So this parabola is inverted. Ulta hoga. This parabola is inverted, having vertex at 2, 4. I need your responses meanwhile. देखो बच्चा, this is x-axis, this is y-axis. Hit the like button, all of you. Now, parabola will be like this, inverted. Okay. So, vertex is at 2, 4. So, let us say this is the vertex. This vertex is 2, 4. Vertex is 2, 4. Now, this is the inverted parabola. Okay, sir. So, if this is inverted parabola, it will be cutting x-axis at 2 points. Yes, it will be intersecting x-axis at 2 points. So I want to know these points where this parabola will be cutting the x-axis. So whenever you want to find the intersection of any curve with x-axis, intersection of parabola y equal to 4x minus x square with what? With x-axis. What you have to do? Put y equal to 0. Put y equal to 0, you will be getting the intersection with x-axis. So one value will be 0, another value will be 4. On x-axis, y coordinate is already 0. So one point is 0, 0, another point is 4, 0. So these are the 2 points where my parabola is cutting the x-axis. So I am damn sure that my parabola is passing through origin. Parabola कहाँ से पास हो रहा है? सर origin से पास हो रहा है. So one point is origin, another point is this one, 4, 0. Now, this parabola is intersected by this line y equal to x. All of us know what is this y equal to x. Sir, y equal to x is a straight line, of course, passing through origin, making an angle of 45 degree with x-axis. So I will be considering a line. Hafiz bhai, एक line बनाएंगे, line. हाँ, line मारना नहीं, line बनाना है. So this is the line. So this line is y equal to x. So if at all we calculate these intersection points of this line and parabola, then we will be able to calculate the limits. So obviously this point is origin, and this point, if you solve y equal to x with the equation of parabola, you will get this point is 3, 3. Yes. So I have got the bounded area. What is the bounded area? Bounded area between parabola and line. I have got the bounded area between parabola and line. So this is the region. Okay. Now let us name it as R. Let R is our region of integration. कुछ नाम दे दो इसको. O, A, चलो V है ना. Okay, V and O. O, A, V, O. Okay, sir. So let us first integrate with respect to y and then with respect to x. तो पहले हम y के रिस्पेक्ट में इंटीग्रेट करना चाहते हैं, बाद में x के रिस्पेक्ट में. So I will be drawing a strip PQ parallel to y-axis. नीचे वाला P, ऊपर वाला Q. हफीज भाई, शेख हफीज बादशाह, the lower point should be P, upper point should be Q. Remember. So y1 is lying on this line. What is the equation of this line? Y equal to x. So y1 will be x. Q point is lying on this parabola. Q point is lying on this parabola. From the equation of this parabola, what is the value of y? 4x minus x square. I need your responses. Now, since this is a vertical strip, slide it horizontally from left extreme to right extreme. So, from O to A, from O, x1 will be 0, and from A, x2 will be 3. So, we have got the limits. Now, what is the bounded area? That bounded area will be double integration over the region R 1 into dx dy. Sir, we want to integrate first with respect to y. पहले हम y के रिस्पेक्ट में इंटीग्रेट करेंगे. So y1 to y2 will be inner integral, and of course x1 to x2 will be outer integral. Now बोलो बच्चा, what are the limits? Limits क्या हैं? Limits of y1 and y2. Already we determined x and 4x minus x square. x1, x2, 0 and 3. I think now all of you can solve this. This is just a 12th standard level question. So integration of 1 will be y. Limits are x to 4x minus x square. And then we have dx. Upper limit is 4x minus x square. Lower limit is x. So 4x minus x square minus x will be 3x minus x square. चलो भाई एक बार और इंटीग्रेट करते हैं with respect to x. चलिए, so what you will be getting? 3x square by 2 minus x cube by 3. Limits are 0 to 4. Apply the limits. 4 is the upper limit. 16 3s are 48. 48 by 2 minus 64 by 3. Limits are 0 to 3. Last limits. I have done a mistake. This should be 3. This should be 3. और इसी के साथ कुछ चेंजेस अभी कर देता हूँ, 2 मिनट भी नहीं लगेंगे, विद इन सेकेंड्स. सो 3 स्क्वायर इज 9, 9 3 are 27, 27 by 2. हाँ भाई भाषा, करेक्ट कर दिया. सो 3 क्यूब इज 27, 27 by 3 will be 9. 4.5 should be the answer. साढ़े 4 square units is the answer for this area. So take the screenshot. We'll move to the next. चलिए ले लो स्क्रीनशॉट. Hit the like button. Share the link of this session to more and more candidates. Next. Sheikh Hafiz, you can try this question. Nasir, find the area outside the circle r equal to a cos theta and inside the circle r equal to 2a cos theta. चलिए r equal to a cos theta is a circle. Center at a comma 0 and radius equal to a. Sorry, center will be a by 2 and radius will be a by 2. First one. R equal to twice a cos theta. This is again a circle. This is having center at a comma 0 and radius equal to a. So we will be considering these two circles. This is our x-axis. This is y-axis. Now, one circle is having center at a by 2 comma 0 and radius equal to a by 2. So this will be passing through origin. So this point is a by 2 comma 0, and this point will radius is a, so a by 2 and again a by 2, this point will be a comma 0. So this a comma 0 is the center of second circle. Second circle is having center a comma 0 and radius is equal to a. Okay sir. सी सो देखो बच्चा, शेक देखो भाई, ये जो है दिस आउटर सर्कल इज आर इक्वल टू 2a cos theta and this inner circle is r equal to a cos theta. Take care. Now find the area outside the smaller circle and inside the bigger circle. Okay, so I will shade the region shade कर लेते हैं भाई. See it. This area you have to calculate. Bacha, conventionally this is very easy question. If you know the radius of the bigger circle, you can calculate the bigger circle area and subtract the smaller circle area from it. Easily that can be done. Okay. But using double integration, we will be verifying the things here. Okay. Yes, sir. So what I am assuming here, that this is the point A, this is B, and let us say this is O. Let us give some name here, C. So let R is our region of integration. Let us say R1 is our region of integration. A, B, C, O. A, B, C, O, again back to A. So starting from A, see, starting from A, B, C, O and A. So what I have assumed here, I have assumed that only the upper half is my region of integration. I assume that this upper half is the region of integration. Okay, because I know that whatever is the area of this upper half, the same is the area of the lower half. Okay, so the total area will be 2 times double integration over the region R1 r dr d theta. So first of all, this time we have to integrate with respect to polar coordinates. We have to integrate with respect to polar coordinates. One point, we are integrating over the region R1. R1 means this upper portion, this green shaded region. This is my region R1. So if I am integrating this over the region R1, I will be getting the area of this upper half. So if this integration over the region R1 is multiplied by 2, then I will be getting the total shaded area, total required area. Okay. So since this shaded area is symmetrical about AB, whatever is the portion above AB, the same is the area of the portion below AB. So why we should make it complicated? We will make it easier. We will just calculate the area of the upper half and then multiply it by 2. That's what I have done here. Okay. So we will be drawing a radial strip. एक radial strip बनाना होगा. Okay. So OP is the radial strip, but I will shade only that portion of the radial strip which is lying in the region R1. Now please concentrate, but a very important step is coming your way. See, from this point you should calculate R1. From this point you should calculate R1, and from this point you should calculate R2. So R1 is lying on the inner circle, and inner circle equation is A cos theta. R2 is obtained from point P. Point P is lying on the outer circle. Now rotate it along line AB. Along line AB, theta is 0. And we have to rotate this strip from theta equal to 0 to theta equal to pi by 2, so that this upper half will be covered completely. Sir, we got it. So theta 1 equal to 0 and theta 2 equal to pi by 4. These are the limits. So apply these limits in this double integration, you will get the answer. So area 2 times then integration, outer integration with respect to theta, inner integration with respect to r dr d theta. Now what is theta 1, theta 2? Bolo bachcho. Theta 1 and theta 2 are 0 to pi by 2. R1 is A cos theta. Sir, R2 is 2A cos theta. Already we obtained the limits. Now calculate this integration. Lag jaiye kaam pe. So 2 times theta 1 say theta 2. Then integration with respect to r will be r square by 2. This 2 and this 2 gets cancelled. Then R1 is A cos theta. Yes, sir. R2 is 2A cos theta. So A will be theta 1 to theta 2. That is 0 to pi by 2. In place of R, put 2A cos theta. So R square will be 4A square cos square theta minus. Lower limit is A cos theta. So A square cos square theta. So we can take, see it, 4A square minus A square. 4A square cos square theta minus A square cos square theta. This will be 3A square cos square theta. Cos square theta cannot be directly integrated. So just what you can do here, 1 plus cos 2 theta upon 2. Yes. So now you can integrate this. 3A square by 2. Integration of 1 will be theta. Cos 2 theta integration will be sin 2 theta divided by 2. Limits are 0 to pi by 2. Lower bound will be 0. So 3A square pi by 4. This will be the answer. And as I already told you that we can easily calculate it conventionally by, see, in our 10th standard, 8th standard, 7th standard, we have learned what is the area of the circle, pi r square. So radius of the outer circle is A. So area of the bigger circle is pi a square minus the area of the smaller circle. Your answer will be again 3 by 4 pi a square. So here I want to tell you the process. So if both the answers matches, then definitely you can rely, yes sir, this method is good, this method is correct that we can apply this method for some difficult integrations also. You can take the screenshot, all of you. I request all of you to hit the like button. I need your response. Understood this one? Take the screenshot. I'll move to the next. So another important part here is, here our strip's center of rotation is origin O, which is lying outside the region of integration. Remember, our strip's center of rotation is lying outside the region of integration. So radial strip's center of rotation will be always lying at origin. Radial strip's center of rotation is always lying at origin. But you have to calculate R1 and R2 from those points which are lying in the region of integration. So from this point, this is the start of the region. I will be getting R1, and from this point I will be getting R2. Next. Take the screenshot, all of you. We'll move to the next. So this is similar to our first question. You just take the screenshot and try by your own. First question. Just try it by your own. So this is an information regarding the Gradeup green card. You can take Gradeup super subscription and you can avail this green card, so that you will be able to use this. Yes, you can watch structured live courses, you can have mock test, you can have the test series, everything on this subscription. Of course, you can use my code to avail the 20% discount, Joshi20. Now, coming on to the volume calculation using double integrals. How to calculate volume using double integrals? Important one. How to calculate volume using double integrations. See here, bacha. Suppose you are having a 3D shape. Suppose we are having a cylinder. So, if I provide you the area of cross section of this bottom, if you know the area of cross section of this bottom face, let us say A, and you are aware of the height h, then what is the volume of this cylinder, bacha? Ankur Singh, beta, Vision 2022 is recently launched, and that is the best course for you if you are in second year. Haji. And you can of course talk to the team. That number is coming on the screen. You can just talk to the person. I'll show you the number again. Vision batch is good. So, what is the volume? What is the volume for this? Volume for this will be area of cross section multiplied by height. area of cross section multiplied by height. Okay, now if this drum, if this cylinder is placed in xy plane, if this cylinder is placed in xy plane such that its bottom face is lying in xy plane, okay, then this is your region R. This cross section area is your region R. So area is double integration over the region R dx dy. Already you have gone through that if the region is lying in the xy plane, the region's area of that region can be calculated by double integration in the xy plane, right? Yes, sir. But if you multiply it by the height, say h, then this will turn to be volume. Since h is constant, either you write h outside or inside, it will not make any difference. So this will be your volume. Okay, so this equation gives me an idea to generate the volume formula using double integration. Volume is V double integration over the region R, where R is the bottom face lying in the xy plane, and yes, Z is the height of the cylinder or height of the 3D shape dx dy. Now this Z is not always constant. This Z can be function of xy. And I know that, I believe that you can solve this double integration with respect to x and y. Yes, sir. So what is this R? R is the bottom face. What is this Z? Sir, Z is the top face. अरे भाई अगर 3D shape है, if you are having 3D shape, then of course you will be having some bottom face and one top face. So bottom face is region R, which is present in the xy plane, and top face is nothing but Z, which will be given in the problem. So Z will be given in terms of x and y always. So Z represents top face, and following this formula, volume equal to double integration over the region R, Z dx dy, you will be able to calculate the volume. Okay. So I already told you that this H will not be always constant. This H can be variable also. So when H is variable, so that variable is represented by Z. Okay. So this Z represents top face, R represents bottom face, that is region R lying in the XY plane. So from this XY plane, from this region R, you will be able to calculate the limits of integration. Z is already mentioned in the question. Z will be mentioned in the question. So limits will be with you. Order you have to assume something. Z will be given in the problem and you can calculate the volume. We'll see one example. Take the screenshot of this. Requesting all of you to hit the like button. See here. In this problem, Z is given by x plus y. Okay, sir. And find the volume under the plane Z equal to x plus y. So this is the top face. This is our top face of the 3D shape. This is the top face of the 3D shape. And above the area cut from the first quadrant of the ellipse. So this is an ellipse whose first quadrant is the region of integration. So 4x square plus 9y square equal to 36. This is nothing but bottom face. So divide by 36 both sides. X square by 9, y square by 4. So of course we can have an ellipse. So only first quadrant of this ellipse, is your bottom face, huh? So yes sir, this ellipse is cutting. This ellipse is cutting x-axis at a distance 3 and y-axis at a height 2. So this point will be on x-axis, so 3, 0. This point is on y-axis, so 0, 2. So this is the region of integration. Sir, how to calculate the volume? Volume can be calculated by double integration over the region R, z dx dy. Okay, sir. So double integration over the region R. What is z? Sir, z is given as x plus y in the problem. I wish to integrate first with respect to y, then with respect to x. So x will be my outer integral, y will be my inner integral, x plus y is the integrand function, dy and dx. Now what is needed? Sir, we need the limits. So limits will be obtained from region R, that is the first quadrant of the ellipse. So we will be drawing a strip PQ parallel to y-axis in region of integration. So P point will give me y1. So y1 will be 0. And Q point will give me y2. So y2, Q point is lying on this ellipse. So bacha 9y square equal to 36 minus 4x square. So y square will be 36 minus 4x square upon 9. So if you take square root and 4 common from the numerator, you will get 2 by 3. 9 minus x square. 9 minus x square, that is 3 square minus x square. Okay, sir. So y2 is 2 by 3 under root 9 minus x square. So we got the limits of y. So now the limits of x. So slide this vertical strip from left extreme to right extreme. Left extreme means this one, x equal to 0 and here x equal to 3. So we got the limits 0 to 2 by 3 root of 9 minus x square and it is 0 to 3. Now requesting all of you to integrate this. So outer integral remain as it is. Integration of x with respect to y. Arey bhaiya, x will be constant. So integration of 1 will be y. Integration of y with respect to y square by 2. Limits with respect to y. Limits hongi y ki. So y1 will be 0 and y2 will be 2 by 3 root of 9 minus x square. Hafiz, beta, from last 3-4 classes, whatever comment you are making, whatever comments you are doing, I am not able to understand your comments because either they are grammatically incorrect or they are not in the context. So you have to do proper comments so that the person on the other side can understand. So 2 by 3 root of 9 minus x square. Y1 equal to 0. Now we have dx. Put the limits. Put the limits here. Y. X as it is. In place of y, 2 by 3 root of 9 minus x square. Plus y square by 2. So in place of y, when you put this term and square it, it will become 4 by 9. Already there is 2 in the denominator. This will become 2 by 9, 9 minus x square. Lower bound is y equal to 0. When you put in these two places, the result will be 0. Now you can separate this into two parts. That will be easier. So volume will be 1 by 3 out, 0 to 3, 2x root of this first term, root of 9 minus x square. Power 1 by 2 dx. This is my first term. Then 2 by 9. Again integration from 0 to 3. I have just separated it into two parts. 9 minus x square dx. Yes, we are moving the strip from left to right only. From left extreme I got 0, from right extreme I got 3. Vertical strip should be slided horizontally. I am not moving from x-axis to y-axis. I am not moving from y-axis to x-axis. I am moving from left to right. Left to right. Left to right जाना है. कहां से लाते हो? y-axis से x-axis, x-axis से y-axis. I have never told like this. मैंने कभी भी ऐसा नहीं कहा. And you are following it wrongly by your own way. From left extreme to right extreme. So what is the value of x here? X equal to 0. What is the value of x here? X equal to 3. अरे भाई मेरे, मैं हर क्लास में शुरुआत में बोल चुका हूं कि if it is vertical strip you have to move from left to right. If it is horizontal strip you have to move from bottom to top. ये साइन कन्वेंशन है. Still if you want to do something else, it's your choice, your discretion. That is not the rule. ठीक है, वो गलत होगा. 4 दिन से गाड़ी आपकी वहीं पे अटकी है. See it. So 9 minus x square. The derivative of this bracket. Derivative of this bracket is minus 2x. So I am adjusting with a minus sign. I am adjusting with a minus sign here. So minus sign out. Derivative of this bracket is minus 2x. So derivative of this function is written adjacent to it. Answer will be bracket to the power n plus 1 upon n plus 1. Limits 0 to 3. Integration of 9. Integration of x square. X cube by 3. Limits 0 to 3. चलिए सॉल्व कर लीजिए. So minus 2 by 9. Put upper limit x equal to 3, that will be 0. Put x equal to 0, we will be getting 3 cube, that is 27. 9 3s are 27. 27 minus 9, that will be 18. So our answer will be 10 cubic minutes. Vertical strip should be moved from left to right. Horizontal strip should be moved from bottom to top. These are the rules. So we have to follow these protocols. If not, your answer will be having some sign differences. Dheeraj Sani, there are many books, but there is Thomas Calculus, there is Krasik, B.S. Grewal, Dr. D.T. Deshmukh. I have gone through all these books. These books are just placed behind me. Almost 9 books are there. But ultimately, whatever book is easier for you, whatever books are easier for you, whatever books you have first read and understood, follow those books only. So, at this, I will be stopping this session. Thanks a lot. शेख भाई, rules follow करना होते हैं. अगर हम rules follow नहीं करेंगे, if we do not follow the rules, then our answers will be differing. Sign का कुछ problem हो जाएगा, limits का कुछ problem हो जाएगा. So these are the rules that you have to follow. So I request all my students to hit the like button. First one, do follow me on Gradeup app. आप Gradeup app पे मुझे follow कीजिए. You will be getting notified regarding my classes, regarding my free classes, because I take free classes on app as well. App पे भी लेता हूँ बहुत सारी classes free में. So thanks a lot, and really I enjoyed teaching you. So I need your responses. So if at all I am not getting the responses from students, I will stop these YouTube sessions maybe after finishing this vector calculus. If I am not getting your response during the class time, I will not come to the YouTube for these sessions again. Okay, so it all depends on your choice and your response. Thanks a lot. We'll meet tomorrow. Take care of yourself, take care of your parents, and yes, thanks a lot. Bye bye.